The next group of problems are the rest of the evens from assignment 4.9a. I have erased the rules. I will talk through the rules as I use them. Again, you should practice on memorizing the antidifferentiation rules. 22. The antiderivative of pi with respect to t. Pi is a constant. So like we said, the antiderivative of 1 was x with respect to x. So antiderivative of pi is going to be pi t plus c. The antiderivative of a sum or a difference is the sum or difference of the antiderivatives. I do not need you to break this apart like this, but this is what we're going to be doing. 3u to the negative 2 minus the antiderivative of 4u squared plus the antiderivative of 1. Forgot all the du's here. If you do break, you do need the du with each one of those. So I'm going to add 1 to the exponent, so that's going to become a negative 1, and divide by negative 1, so this becomes a negative 3u to the negative 1. Add 1 to the exponent becomes 3. So I have minus 4u cubed, and then divide by the 3. And that is just going to be u. So this next one I'm not going to break up, but I am going to rewrite it so it follows our rules. I'm going to rewrite it as the antiderivative of 5t to the negative 2 plus 4t squared. Add 1 to the exponent. That gives me t to the negative 1. Divide by the new exponent. So I have 5, negative 5 halves. Add 1 to the exponent. It's going to give me t cubed. Divide by the new exponent is plus 4 thirds. And you can leave, and then up here I forgot my plus c. Here I need my plus c. You can leave it like this, or you can rewrite it as negative 5 over 2t plus 4 thirds t cubed plus c. I will accept either one of those two answers. We do not have a power rule for antiderivatives. We'll have some other methods that we can use to do, not power, but product rules for antiderivatives. We'll have several methods coming up in future sections that help us deal with some of these things. But the easiest way to deal with this one is to distribute the m in first. 5m times 12m cubed is 60m to the 4th. 5 times negative 10 is negative 50. M times m is m squared with respect to m. Add 1 to the exponent. Divide by the new exponent. 60 divided by 5 is 12. Add 1 to the exponent. Divide by the new exponent. Negative 50 divided by 3 is negative 50 thirds plus c. We didn't have any rules for roots, so I'm going to rewrite this root as an exponent. I'm going to rewrite it as 6x to the 1/3 dx. I'm going to add 1 to the exponent. 1/3 plus 1 is 4 thirds. And I'm going to divide by the new exponent. Dividing by an exponent is the same thing as multiplying by its reciprocal. So I end up with 18 fourths, which is 9 halves. So I have 9 halves x to the 4 thirds plus c. Add 1 to the exponent. I get 4 thirds. Divide by the new exponent. Add 1 to the exponent. Negative 1/3 plus 3 thirds is 2 thirds. Divide by the new exponent. Now I'm going to add plus c. Now I'm going to simplify. 4/3 times 3/4 is just 3. So this becomes 3z to the 4/3. This will become minus 3/2 z to the 2/3 plus c. So these are dealing with roots. Turn your roots into exponents and deal with them just using the general power rule. Anytime you have a rational function where the degree of the denominator is less than or equal to the degree of the numerator, divide through first. So what I'm going to do is I'm going to split this fraction up into two parts, and I'm going to divide each of the parts. So 12t to the 8th divided by t cubed is 12t to the 5th. T divided by t cubed is going to be t to the negative 2. And now I can just use the general power rule twice. Add one of the exponent. Divide by the new exponent. 12 divided by 6 is 2. Add one of the exponent. Divide by the new exponent, negative 1. Negative divided by a negative is a positive, plus c. I can do the first part, e to the t. I need to rewrite this as t to the 1/2. So it's the integral or antiderivative of e to the t plus 2t to the 1/2 dt. Antiderivative of e to the t is e to the t. Add one of the exponents, so I'm going to get t to the 3/2 divided by the new exponent of 3/2 plus c. Simplify. This is going to end up being 4/3 t to the 3/2 plus c. Let me look at the next one. Wrote it a little bit off here. I'm going to tell you not to do 56. I'm going to come back to that one at the end. The reason why is we do not have a rule for e to the 12x, but we're going to talk through that at the end. We will learn, I'll formalize this next week on how to do substitutions to do this one. So the last one that you have to do for evens is 58. Again, it's a rational function where the denominator has a degree less than the numerator, so I'm going to do division first. So I'm going to end up with 10t to the 4th minus 3t to the negative 1. Basically what I want to do is I want to rewrite it in a way that I can use my rules, except that t to the negative 1 I can't use because I don't have that rule, but I have 3 over t. So add one to the exponent, t to the 5th. Divide by the new exponent. 10 divided by 5 is 2. The antiderivative of 1 over t dt would be the ln absolute value of t times the negative 3 in front, plus c. We can do the first part of this one. We could do this one if it was just e to the x. Okay? Well, let's think about this. What is the derivative of e to the 12x? Well, we would do a u substitution. We would let u equal 12x, and then we have du is equal to 12 dx, or du over dx is 12 dx. So if we did the chain rule on this, we would have the derivative of the outside function, except don't write x, where x goes, write the inside function, times the derivative of the inside function. So if I was taking the derivative of e to the 12x, I'd end up multiplying by 12. If I'm taking the antiderivative, instead of multiplying by 12, I'm going to end up dividing by 12. Okay? When we get all done, doing this, we're going to take the derivative of it and make sure we get back to the original equation. So again, I'm going to formalize how I do these things. We're actually going to do some substitutions next chapter. But you can also do it with some logical thinking. Hey, when I do the derivative, I end up multiplying by 12. So when I do the antiderivative, I'm going to end up dividing by 12. So let's find the antiderivative. And then we're going to take the derivative of it to make sure we get back to the original function. So add 1 to the exponent. Divide by the new exponent. 22 divided by 11 is 2. Minus, well, I'm just going to copy the e to the 12x, and instead of multiplying by 12, I'm going to divide by 12. Negative 24 divided by 12 is negative 2 plus c. So now let's take the derivative of this whole thing and see what we get. Okay, so the derivative says multiply by the power and subtract 1 from the power. Okay, I'm going to let u equal 12x, du equals du over dx is 12. So I end up with minus 2 times the function times the derivative of the inside function. And the derivative of constant is 0. 12 times negative 2 is negative 24. I didn't multiply right. 11 times 2 is 22. So I end up with 22x to the 10th minus 24e to the 12x. And that is, in fact, what I started with. Again, 56 you are not responsible for right now. You will be responsible for it next week after we do substitutions. You won't have to think about it logically. We'll actually come up with a format to do the substitutions to come up with these answers.